Inside a perfectly reflecting cavity, the wavelength of a standing electromagnetic wave decreases by 25% due to compression. You have to determine the percentage increase in frequency and the percentage increase in photon energy. Now let's denote the initial wavelength by lambda 1 and the final wavelength by lambda 2, which is 0.75 times lambda 1. A 25% decrease in wavelength means the new wavelength is 75% of the original wavelength. Now you know that the speed of light is expressed as the product of frequency and its wavelength. C is equal to f lambda. Speed of light is constant, so f lambda will be equal to constant. Or we can say that frequency is equal to constant times 1 over lambda, moving lambda from left side to right side. So we'll get frequency is inversely proportional to lambda, the wavelength of light. Now if the initial value of wavelength is considered as lambda 1, then the final wavelength is 25% less than the initial wavelength. So we can calculate the value of lambda 2 as lambda 1 minus 25% of lambda 1, which is equal to 25 over 100. So we can write this equation as 1 minus 0.25 times lambda. We'll take lambda common because it is in both the terms. So solving this equation, you will get 0.75 times lambda 1. Thus, the value of lambda 2 is equal to 0.75 times lambda 1. Now, the frequency, initial frequency, f1 is expressed as constant times 1 over lambda 1 and f2 is equal to constant times 1 over lambda 2. Now, taking the ratio or dividing equation 2 by equation 1, we'll get f2 over f1 equals to lambda 1 over lambda 2, which is equal to lambda 1 over 0.75 times lambda 1. We use the value of lambda 2, which is equal to 0.75 lambda 1. Now, f2 over f1 will be equal to 1 over 0.75. Lambda 1 will be cancelled and you get 1.33 as the ratio of f2 to f1. The ratio of f2 to f1 is equal to 1.33, which means that f2, the final frequency, is 1.33 times f1. And the percentage increase is determined as 1.33 minus 1 into 100, which is equal to 33.3%. So the frequency increases by 33.3%. Now the next step is to calculate the change in photon energy. So here we'll use Planck's equation, which is given by E is equal to hf, where h is the Planck's constant and it is constant itself. So E is proportional to the frequency. So rewriting the equations for E2 to E1, we'll get F2 over F1, which is equal to 1.33. Again, the percentage increase can be determined in a similar way as 1.33 minus 1 into 100, which is again equal to 33.3%. Thus, the photon energy increases by 33.3%. Now, let's consider what this figure is actually telling us. On the left, we have a standing electromagnetic wave inside a perfectly reflecting cavity before compression. Notice that the wave has a longer wavelength represented by lambda 1. Because the wavelength is longer, there are fewer wave crests inside the cavity. Now look at the right side. After the cavity is compressed, the standing wave must fit into a smaller space. As a result, its wavelength becomes 25% shorter. So, lambda 2, the final wavelength of the compressed wave, is given by 0.75 times lambda 1. Although the speed of light remains constant, shortening the wavelength forces the wave to oscillate more rapidly. That's why the first row at the bottom shows the wavelength decreases. The next arrow tells us what happens next. Since speed of light is constant, so frequency is inversely proportional to wavelength. So when the wavelength becomes 75% of its original value, the frequency becomes 33.3% of the original value. That is, the frequency increases. Now look at the last panel. Using the energy of a photon is directly proportional to its frequency. Since the frequency increases by 33.3%, the photon energy also increases by 33.3%. So the entire figure tells a beautiful cause and effect story. Compression, shorter wavelength, higher frequency, higher photon energy. The key lesson is not just the calculation. It's understanding that inverse relationships are nonlinear. A 25% decrease in wavelength does not produce a 25% increase in frequency. It produces a 33.3% increase because frequency varies as the reciprocal of wavelength. This is precisely why physics rewards conceptual understanding, not just memorizing formulas. Did you get 33.3%? Or did the inverse relationship surprise you? Share your answer in the comments. And if you enjoy concept-based physics, subscribe for more physics reflections. Stay curious, stay conscious.